All right, so you've watched the video, so you see the technique. You may have collected some of the data. I just want to walk through the report form a little bit. Frankly, more than I would have done in a normal situation, but we are not in a normal situation. So in part A, you calculated the amount of solids that you needed to produce these various solutions. So here's a place for you to show your work. Now, I've actually done this just by necessity. So you'll be able to have me effectively check your work by, can you get to the 34 grams? Question 2 asks you to calculate the amount of sodium chloride in the 2.5 molar solution. So that answer should be here. You'll have to calculate those other three quantities, masses. And then since you don't have the experimental data for those three, you'll just go ahead and use those values. So calculate, plug in your values there. Now there's the experimental data. And I put that in a PDF, so you don't have to scurry to write this down. The very next file in the assignment is the PDF. So there are the values, freezing point, melting points that we got, and boiling points that we got. And I've given an example of the calculation. You'll see it's easy. I just didn't want anybody to get caught up in semantics and get a bunch of screwy numbers. But there's the arithmetic. You'll put the value, arithmetic value. And so you'll finish that table with the freezing point change for the solution and the boiling point change for each solution. On the second page of the report then, after you've got that data, we just say, hey, in general, how does the freezing point of a solution compare to the freezing point of pure solvent? And then the same thing for boiling point. Questions 7 and 8 get at this idea of, well, I dissolve these things in water. There's my sugar, solid, and I dissolved it in water. And then I did the same thing with sodium chloride. The appearances, they did exactly the same thing. I swirled them around. Ultimately, I got a nice clear solution. And this stuff has become aqueous, and this has become aqueous. Don't overthink this. This is very, very, very simple. This one, however, you're going to have to think, well, wait a minute, strong electrolytes, certainly it's going to be aqueous over here, but there's a very big difference in the way that looks. From there, then, you go to table 3. Now, this often confuses students. These are in a different order than table 2. So when you're looking up your freezing point depressions, be sure to, oh yeah, there's the sugar, 1 molarity. There's the sodium chloride, 1 molarity. So this will be in a different order than they are on table 2. Now, particle concentration is alluding to something about this non-electrolyte and strong electrolyte. And then 8b says, okay, now you've got these particle concentrations and you've got these freezing point depressions. Is there any pattern or trend or correlation? The last question I love, but it's going to be a little tricky. We know that in general, all things being the same, as I go from a solid to a liquid to a gas, we've qualitatively said, well, the entropy is somehow different. So we've got entropy over here and a place to think about, well, what has the most entropy? What has the least entropy? Where would those go in those 3 positions? Solid, liquid, or gas. And I've got 3 positions. And then we've entered where the entropy, this absolute entropy is for the solution right there. And we ask you about some things. Well, if I think about going from the liquid to a solid, or the solution, liquid to a gas, or the solution to a gas, what's my change in entropy over here? Is it positive or negative? And which one's greater? And then we get to something we can do that's really, really cool, I think. It says, okay, if delta H is about the same for a solution evaporating or the pure solvent evaporating, and now I have an idea about the relative delta S for the solution evaporating or boiling, or the pure solvent boiling. And if I assume that delta G has to really be about the same, maybe a little bit fuzzy there, but let's assume delta G has to be the same, what does T have to be? What does the relative temperature have to be for those two different processes to happen? All right, that's it. The answer key will be posted after the assignment is due. Thanks for your patience and good luck. Remember, there'll be a discussion board attached to this, so you're welcome to collaborate with classmates. You're welcome to contact your lab instructor, of course, and or your lecture instructor to get some help. Good luck, folks. Hang in there. We're almost done.